Direct variation. Direct variation applies when the variables have a proportional relationship. Sometimes it's referred to as having a direct variation or a proportional variation, but basically it refers to a linear relationship. The equation for direct variation is y equals kx, where k is referred to as the constant of proportionality. But if you look at this k is the same as the m in our linear equations. So the constant of proportionality is really just the slope. It is the rate of change. When you're asked to find an equation of variation, you're going to use the information you're given to first find the constant of proportionality, and then write the equation using that value for the k. Once you have the equation, of course, you can use that to help you solve problems. So let's look at this situation. Consider that the number of people P at a concert vary directly as the number of tickets sold T. So just that tells me that there's a relationship here, that P is equal to K times T. For every 10 tickets sold, there are 9.5 people at the concert. Find the equation to represent this situation. So for every 10 tickets sold, that means when T has a value of 10, the number of people at the concert has a value of 9.5. So what we do is we plug these numbers into our equation for T and P to find out what our constant is. So we have 9.5 equals K times 10. So to get the K, of course, we divide by 10. So 9.5 divided by 10 would be 0.95. So that is my K. That is my constant of proportionality. My equation is P equals 0.95 T. So the number of people at the concert equals 0.95 times the number of tickets sold. Let's use this equation in the next couple of problems. Use the equation to find the number of people at the concert if 20,000 tickets are sold. So here's my equation. P equals 0.95 T. This time I know that I want to use 20,000 for the number of tickets. So P would equal 0.95 times 20,000. So I'm going to take my calculator out, get it larger here. Turn it on and multiply 0.95 times 20,000. That tells us that there would be 19,000 people at that concert. Now the second part of this problem says use the same equation to find the number of tickets sold if there were 50,000 people attending the concert. So this time I use the same basic equation. P equals 0.95 times T. But this time I don't know the number of tickets, I know the number of people attending. So I would have 50,000 equals 0.95 times T. So in this case I need to divide by 0.95 to solve for t. So that's going to give me 50,000 divided by 0.95. There would have been, let's round this since we're talking about the number of people. Let's round it to the nearest person. So that would be 52,632 tickets sold. I'm sorry, it's not number of people, it's number of tickets. So we still have to round it to the nearest whole number. So this would have been the number of tickets sold, just a few more tickets than the number of people who were at the concert.